So what is NVIDIA's roadmap? In this video we are going to look at NVIDIA's product roadmap, the strategic initiative NVIDIA pursues, and yeah, we will focus on AI factories and beyond. So let's start maybe with a basic question to get a better feeling about what NVIDIA is about. So NVIDIA is all about accelerated computing. They even invented this term. It is about, like here in blue, you see over the last 3 decades, you see in blue Moore's law playing out, right? So the number of operations per second, and you see that the CPU performance in blue has actually improved exponentially. So if you have a straight line in a log linear chart, then we have exponential improvement here. So we have seen exponential improvement between say the 1990s and the 2010. But then we somehow converged, right? We have this blue line. We have seen a convergence of CPU performance, and this means that our ability to perform operations per second, to perform compute, has not improved for CPUs. So CPUs have converged, but NVIDIA has managed to accelerate the performance of CPUs by means of GPUs. So they started with graphical computing, and they have enriched, say, the operations that are able to run efficiently in parallel. They have managed to push those type of operations that are easily parallelizable across thousands of cores to GPUs. And the GPUs have become larger and larger and larger. So the GPUs now, today, are not the type of GPUs you have seen 10 years ago that you can purchase. So like for your computer hardware, right, with NVIDIA GeForce card or so. This is not the same animal, right? These days. So maybe let's have a quick tabular overview of accelerated computing. So we compare CPU, central processing units, with GPUs, graphics processing units, and from the architecture point of view, we have CPU has a few cores, like maybe up to 8 cores in your computer, right? Whereas GPUs have thousands and thousands of smaller, more focused, more efficient cores. So focus, I say, it's like a specific purpose. It's not a general purpose processing unit. It's more specific to application specific, right? And being application specific means you can optimize it for the specific tasks you want to optimize for. And as we are in the age of AI, we are currently optimizing for AI training and AI inference, right? And these type of AI tasks are often highly parallelizable. So GPUs are much more efficient. Actually, we can gracefully scale, we can keep scaling exponentially, seeing this 1000x in 10 years by using GPUs. And yeah, this is already so CPUs have limited parallelism. They are more optimized for sequential tasks. So you compute one thing, then you compute the result based on the other thing, like in a spreadsheet, right? Maybe if you have cells that depend on each other. So you compute one cell based on another cell, then you compute the third cell based on the second cell, and the fourth cell based on the third cell, and so on. So this would be like a sequential task. So you compute one thing based on the other. But GPUs are more focused on parallelizable tasks, so where you can run things concurrently. So for example, you compute the output of a neuron based on its input, and you have millions or billions or trillions of neurons, and each neuron independently computes its output based on its inputs. And doing this repeatedly means we can it's like a bazooka compared to bows and arrow, right? You have a huge parallelizable computation. You can run trillions of operations in parallel if you have trillions of smaller cores, right? In theory, so you can really accelerate your computation. Throughput is very high, optimized for data blocks. So you send blocks of data through the. There was this nice visualization. Maybe I can find it here. Visualization, GPU versus CPU gun. Okay, I don't find it. So it was like it was visualization where they shoot a single bullet, and this was like the CPU shooting a single bullet, very targeted, and then shooting thousands of bullets at the same time was the equivalent of a GPU, right? So GPUs are more energy efficient, more scalable. They are better for large data sets that are parallelizable. They are better for AI. You can use like libraries like CUDA or cuDNN to create programs specifically designed for GPUs, i.e. highly parallelizable. And yeah, it's a bit more complex oftentimes to create programs that run on a GPU. But NVIDIA basically focuses on this whole area, right? On GPUs, on accelerated computing. And yeah, so let's maybe have a look at the presentation in SIGGRAPH, I think 8 months ago or so.
Load this 1x, $100 million using general purpose computing and using accelerated computing, Grace Hopper, it would only cost $8 million. $8 million and only 260, not megawatts, yeah, 0.26, 260 kilowatts. So 20 times less power and 12 times less cost.
Okay, so this one is significant. So we have like an orders of magnitude improvement in cost and order of magnitude improvement in energy efficiency by using GPUs. And now let's maybe have a few more seconds of this video because it shows you why NVIDIA is so successful.
This is the reason why accelerated computing is going to be the path forward. And this is the reason why the world's data centers are very quickly transitioning to accelerated computing. And some people say, and you guys might have heard, I don't know who said it, but the more you buy, the more you save. And that's...
Okay, so this was like Jensen Huang, the CEO of NVIDIA, and he obviously sells his vision of accelerated computing based data centers. And every data center, every computer, additional computers on the edge, robotics computers and so on, will come with built-in accelerated computing. And currently NVIDIA is the clear leader in accelerated computing. That's why the market values NVIDIA so hugely, right? So let's start maybe with one product, one specific product. It's the EOS supercomputer, a purpose-built AI factory. AI factory, you can read AI factory is like a data center, right? It's like a supercomputer, data center as a service. So they sell the whole data center. And this whole data center, you can think of this as one GPU. A very, very powerful GPU, right? But it's with so many potentially, but it's just like a huge accelerated computer, right? This is one computer that can run huge amounts of data and you can use it for AI training. So, for example, this NVIDIA's EOS, it's unveiled at Supercomputing 2023, is one of the best, one of the most performed AI supercomputers. And through the DGX cloud, DGX service, DGX AI cloud service, NVIDIA provides this for customers. So customers can get access to these kind of computers. It's like AI training as a service. They can get access to this via all major cloud providers. This is Amazon Web Services, Google Cloud, Amazon, Google Cloud, and Microsoft's Azure. So all major cloud providers actually provide this access to NVIDIA DGX AI. So researchers and decision makers want to access NVIDIA supercomputers and the NVIDIA AI training infrastructure because it's the most cost efficient and the fastest way of training your AI models, right? And here we see like some key features of this AI supercomputer is it consists of 576 DGX H100 systems. Maybe you have heard this H100 GPUs. NVIDIA, in the meantime, has already created H200 computers, but it has also created Maybe I have a chart. Yeah, I have a chart. So NVIDIA's H100 was responsible for the breakout earnings we have seen recently. It's like the Hopper, H for Hopper 100, but they have already introduced an H200 and then also the Blackwell infrastructure. I think it's called HP or something. Maybe not, maybe HB for Hopper Blackwell or something, if I'm not completely mistaken. So you see, what you see here in the chart, the performance, right, of the Blackwell, the new infrastructure, it is much better than the NVIDIA's H100 GPU. And such an AI supercomputer obviously consists of lots and lots of those GPUs, but then you need to connect those GPUs with a communication, right? Because now these GPUs, they communicate data. The GPUs are for processing data. So you get data in, you process the data, and then you get data out. So the bottleneck often is just the data, sending the data in and getting the data out, right? Not the processing, especially if you have such powerful GPUs. So that's why in this EOS supercomputer, it is not only consists of a lot of processing capabilities like these H100s, it also consists of this Quantum 2 InfiniBand with 400 gigabytes per second data transfer speeds. So these are hugely powerful communication devices, so to say, right? And there's a huge market potential. I mean, you can assign any number to it. AI has this significant market potential, and I have yesterday in the Finxter newsletter, I've written extensively about the potential of AI, and not only the potential in terms of the future revenues, but the current revenues. All the most powerful companies today are already AI companies. They already generate huge amounts of revenue with AI. Google is an example. That Google generates like 1.7 million or so per employee. How do they do this in a given year? How do they do this? How can they use their employees as effectively, like squeeze 1.7 million out of every single employee in a given year that works for Google? They can do this with AI. So all of them are already AI companies that create scalable value using artificial intelligence mostly. Okay, the next product we are going to look at quickly is the Blackwell architecture and NVLink. NVLink again is the communication, and Blackwell is the computation. So we all computing infrastructure is always divided in computation and communication. And oftentimes it doesn't make sense to improve computation, right, if you don't also improve communication. If you have a hugely powerful computing device or chip that computes things in a split second, but then you need to wait for the new data to arrive because you have inefficient communication then, or maybe you need to load it from a disk or so, which takes a lot of time, then the bottleneck actually is communication. So NVIDIA optimizes both. And Blackwell GPUs, they start with the GB, so GB, not HB. I said HB previously, but it's GB. GB200 are central to NVIDIA's AI factory vision. They are part of these DGX systems, where people can access NVIDIA AI computation through cloud. They have exaflop level performance and a switch technology that is now even faster. The Blackwell communication is even faster than we have seen previously, right? Here the EOS supercomputer has this InfiniBand with 400 gigabytes per second. This is 0.4 terabyte per second. Now this one has 130 terabytes per second. So it's like 200 times more powerful. It's 2 orders of magnitude, even more than 2 orders of magnitude, more powerful communication device. So the NVLink switch technology is a massive interconnected bandwidth between those super powerful GPUs. And the market potential is just massive, right? I mean, this thing is able to train trillion parameter models. So we will see an explosion in AI capabilities. So in my opinion, the Blackwell, which is just the coming most exciting NVIDIA product, will be the blockbuster AI product of our times. And we will see AI doing things that we previously couldn't even dream of, right? Good. Let's have a look at some other products that NVIDIA is involved in, because NVIDIA is not just an infrastructure or hardware company. Like even designing the Blackwell, it's more the design task, right, than a hardware production task. It is more about designing those things to be very efficient than just producing them. Producing them is actually done by TSMC and other manufacturers. NVIDIA just, in quotation marks, designs those chips. But of course, they also do some assembly and some manufacturing. So it's highly complicated production capabilities. Like if you think of Tesla, you think of a hardware company, right? So they produce computers on wheels, or maybe robots on wheels, right? And NVIDIA actually produces these kind of computational monsters that are as complicated or even more complicated than self-driving cars. So these are very complicated products they design. The mode of those is actually huge. And I have recently created a video on NVIDIA's modes. You can check it out on the Finxter YouTube channel. So please, by the way, give us a like, subscribe to the channel if you want to be on the right side of change, if you want to keep listening to my upcoming NVIDIA and AI videos. Good. NVIDIA's AI software stack consists of many tools, right? Many tools. It's really a software stack. It's really an ecosystem of different applications, different infrastructures. It can be a physical infrastructure, right, like a GPU or an NVLink, communication devices, but it can also be a software or virtual infrastructure, like infrastructure for building generative AI, performing or running data analytics, doing inference, speech AI, vision AI, cybersecurity. So they have lots and lots of those AI software and ecosystem, the whole CUDA stack to program in a parallelized way. This is a programming language for parallelized computing, and many developers use CUDA to express their programs so that these programs can run on GPUs. And NVIDIA is deeply ingrained in this whole AI training and AI inference, and also like other graphical kind of applications, basically all applications that can run on GPUs versus CPUs. So NVIDIA is the leading company in this space, and all these software ecosystem applications they have not only created but also like pushed into the collective culture of software development over 20 years, because they were the first. This is a huge mode they still possess, and that should not be underestimated, because if you want to compete with NVIDIA, you would have to do the same thing, and it is really difficult to change people's habits. Okay, another product is, for example, Jetson AGX, Isaac, and Metropolis, and these systems, also SDKs like software development kits. These platforms provide ways to create advanced robotics and autonomous systems. Here on the picture we see the NVIDIA Isaac SDK that allows us to program all kinds of applications, robotic applications like embodied AI, right? But then we also have like the crude foundational model that also uses some of those systems, like Jetson AGX. Actually, the crude foundational model for humanoid robots is part of the Jetson infrastructure, Jetson AGX platform, for creating those robotics and autonomous systems. So let's have a look at the crude foundational model. It acts as, you can think of it as the mind or the brains of the humanoid robots, right? So they can learn together. They can move in the physical, in the digital world, right? That adheres to physical rules. Like it's a simulation of reality. You could think of it like the Matrix, for example, right? With physics that are really realistic. So you can, but as you are in a simulation, in a digital environment, you can actually perform lots and lots and lots of experiments in the simulated space without needing to do the costly hardware deployment of those humanoid robots. And you can converge to a foundational model that is orchestrated by NVIDIA, right? And then those companies like 1X Technologies, Agility Robotics, Boston Dynamics, Apptronic, Figure AI, Sanctuary AI, Unitree, all these robotics companies, they use this foundational model provided by NVIDIA. So this way, NVIDIA is the biggest competitor of Tesla Optimus, right? The Tesla Optimus bot. So Tesla is basically alone, whereas NVIDIA works together with all those startups to create a foundational model for humanoid robots. And many people don't yet see humanoid robots as something that will actually come and that is actually currently being deployed. And that's why I have prepared a couple of slides with just showing the current state visually of humanoid robots. So this is the humanoid robot by Sanctuary AI, Phoenix, and some of these you can already buy, right? For I think the cheapest one is like 20K or something. So this is Phoenix, general purpose robot. This is by 1X Technologies. The robot, this is actually a collaboration of NVIDIA, OpenAI, and the other companies I don't know. Then you have from Agility Robotics, Digit. The bot can already, it walks a bit differently than other robots. You have Apptronic, also a beautifully looking bot that is already deployed in factories. It already works in factories. We have obviously Boston Dynamics Atlas. You most likely have seen him in videos dancing. We have Figure AIs. I think those are the leaders, except maybe Tesla's Optimus bot that probably is even more capable than Figure AI. And some other bots like Fourier Intelligence GR1, who can already play games like Go and chess completely manually and autonomously. So these bots are definitely coming. Okay, so we have the Unitree H1, I forgot about that. So those bots are coming, and NVIDIA is the biggest competitor of Tesla, and they provide the foundational models for humanoid robots. And my prediction will be that we will see a race between NVIDIA and Tesla to create the most powerful foundational models for humanoid robots. The next product suite by NVIDIA is about digital twins and the Omniverse. The Omniverse is a completely simulated version of reality. Think of it as the Matrix, as I already said. They use this graphics platform like OpenUSD to provide ways for companies to create digital twins for simulation and optimization, to create virtual replicas of their factories, right? So the whole factory in its whole dynamicity is actually replicated virtually in a virtual space that is simulated by Tesla. And it is some real-time simulation and testing that can be done in those virtual factories. So of course you can track your current factory, but you can also test out things. Maybe in your virtual twin, you can do some simulation first before you move objects in your virtual twin, maybe move robots from A to B to be more efficient. You can do it in your digital twin and see how it plays out, right? These kind of simulations are the major way of improving efficiency in the factories of tomorrow. Actually, already we see more and more virtualization and digitization of factories. And this is a process that will just continue. And also NVIDIA, in my view, has the most potent platform, the Omniverse, that actually benefits from these efficiencies of scale and network effects, because now it can work on huge amounts of data by means of, as it hosts thousands and thousands of customers that already use the Omniverse. So it's a huge digital simulated environment, and you can digitize anything, right? With a camera, you can record these things, and it creates you 3D models out of it, and you have your whole factory in a digital sphere. And if you have something in digital sphere, you have all the benefits of digitization, which is like low cost experimentation and stuff. So the Omniverse is also a huge product that is pushed by Jensen Huang personally. So I think that we will see significant revenue open up by this. And of course, as you do this whole graphical virtualization of a graphical space, right, of a 3D space, you need a lot of GPUs. It's very GPU heavy computation. So all of these applications we see, like humanoid robots, the Omniverse, digital twins, all of those will need huge amounts of graphical processing units. So it is just the beginning. So let's have a look at a quick demo of the Omniverse. Sorry for the loud thing. So all of this is simulated stuff, right? It is completely, it looks real, but it's simulated in very in-depth by NVIDIA's GPU technology. Okay, so you get the point, right? Like simulating those flames or waves or maybe the weather data. It's very cost intensive, it involves a lot of computations. One of my friends, PhD friend, was simulating just some noise that was generated by automotive parts for Porsche. So he ran the simulations on 20,000 cores. So he accessed the biggest computing cluster in our university with 20,000 cores at the time, CPU cores. He accessed this cluster to simulate those kind of things. But now you would do it with NVIDIA's GPUs, obviously, because as we already saw on the table, CPU versus GPU and accelerated computing, CPUs are really bad for this kind of work, and we need to use GPUs for the highly parallelizable nature of the computation. Good, then another suite of products come from Edge AI and IoT, Internet of Things. NVIDIA's solution enable like real-time processing on devices for applications that require low latency. Examples are enterprise edge computing, why edge computing? Because computation is pushed to the edge. Computation often doesn't need to be done on a central data center, or maybe cannot even run on a data center for privacy reasons. You need to run it at the edge. So where you need the computation, you need to run it. For example, a humanoid robot or a self-driving car may not be connected to a data center even, right? So it needs to have some own inference. Like your brain is not connected to a central brain or something. It has its own computation capabilities, so you can run inference and can update your mental models. You can update your neural network, so you can do AI training and AI inference in your brain at home without being connected to a central huge brain, right? So it's the same for computation. Computation is pushed to the edge, especially for AI. We will see lots and lots of generative AI and computations and inference and stuff on the AI, and NVIDIA also provides a whole suite of products there. Finally, we have healthcare and life science. They have a platform with NVIDIA Clara. It's a platform for AI applications in healthcare. Examples are like biopharma, medical devices, healthcare, drug discovery, genomics, medical imaging, each of those areas will cause a demand surge for GPU-based computing, and NVIDIA also provides the infrastructure for this. So NVIDIA is a beautifully horizontally and vertically integrated company that it's like a spider, right? It's everywhere. NVIDIA, you will find NVIDIA in your computer at home. You will find it in the data center you use. Like if you use AWS for AI training, you will indirectly use NVIDIA chips. If you talk to your chatbot, if you talk to Google, you will use NVIDIA's computational infrastructure implicitly because they use it for training and inference. If you talk to your humanoid bot in 5 years at home, you will talk to NVIDIA brain, right? NVIDIA powered brain. The foundational model provided by NVIDIA, but also the chips, the inference that runs on NVIDIA chips. So if you sit in your self-driving car and the car drives you to Spain, right, from Germany to Spain in my case, then you will sit in a device that actually is powered its inference compute and its intelligent behavior that is powered by NVIDIA. So NVIDIA is everywhere in every application. It's on the edge, it's in the data centers, it's in all types of software and hardware applications and devices and platforms. You have programming interfaces and programming languages powered by NVIDIA. It is really like the infrastructure that runs the world in AI. Okay, and this slide I already showed you. I actually put it here at the end just to show you that we are just at the beginning. This Hopper actually was the latest breakout earning. It was based on indirectly on sales of the H100, but now we have the Blackwell, which is even better, which is significantly better than the Hopper, and it's capable of 20,000 teraflops. So it continues. It's just the beginning, right? And the total addressable market for AI compute is infinite. So I already presented this slide in another YouTube video on the Finxter channel, but I think it's a great slide because it shows by NVIDIA, by the way, it shows that generative AI is not only about text to text, right? It's not only a chat. It's a multimodality, and they already had this slide before the ChatGPT 4o model came out, the Omni model, right? Where you can put in images, text, videos, speech, multimodality. We will connect like brain waves to image. Also, we will convert anything to everything. It's really transformer technology, literally. We transform any data type and even combinations of data types to any other data type. And we just started with text to text. Text to text was the reason for the recent surge of NVIDIA stock price in the last 2 years, mainly text to text models. But now we will see images and video, generative AI, and those will require orders of magnitude more compute. So we are just in the beginning of compute demand. Maybe as a main takeaway of this overview presentation of NVIDIA's roadmap is that NVIDIA doesn't sell chips, it sells AI factories, data centers, where you like the whole data center, it sells to you, data in, tokens out, and it sells it with different business models, right? For instance, you can rent their data centers, maybe via a third party such as AWS, or you can rent their software infrastructure that indirectly runs on the AI factory, or you can purchase the AI factory yourself if you need the privacy. We also see products such as Sovereign AI by NVIDIA that allows nation states to create their own foundational models independent of the tech giants, so they can remain sovereign, right? It's for nation states. They also will purchase products by NVIDIA to run their own AI solutions. Yeah, they save factories. It's cost efficient, private, and secure. And here you see an example of such a full data center. It's not even like one rack, one of those server racks. It's infinite server racks. Like this AI factory now has 32,000 GPUs, and it costs billions probably. So it's just the beginning. Thanks for watching this video. The main purpose of Finxter is to help you be on the right side of change. If you want to join our free newsletter, feel free to do so. Just go to finxter.com and subscribe to any of the forms that will pop up, and I will keep you on the right side of change with regular emails. Also check out, join our channel. So just give me a like, subscribe to this video, to this channel, and check out the Finxter Academy. You can search Finxter Academy on Google, on ChatGPT, wherever you want. You can go to academy.finxter.com directly and browse our recent courses. The latest course is not even added here to this screenshot. It's about Hugging Face and explaining you how to use Hugging Face to create your local generative AI solutions, where you can create images, text, even hip-hop beats on your local machine with your GPUs on your, maybe GPUs or CPUs on your computer. If you use CPUs, it's like 10 times as slow, or 10 times slower, I should say. And but you can, if you have GPUs or CPUs, doesn't matter. You can run these large language models, mostly based on Llama 3 or so, Meta's platform or foundational model that is also trained on NVIDIA GPUs. On your local machine, right? So running it on your local machine it's a good solution if you have privacy, if you are privacy sensitive, or you want to simply run it for free, don't pay for tokens. So check out the Finxter Academy for all of this. The whole education, AI engineering education, is handled by the Academy. It's a heavy work, the heavy lifting we do on the Academy, and the soft lifting we do on the Finxter.com newsletter. Also, you can also see all Academy courses by simply becoming a channel member here on the Finxter YouTube channel, and I will give you access to the Academy as well. Thanks for watching. Appreciate having you here, and see you in the next video. Bye.